So yesterday there was a day after the classes was over, there was a question about how to get the radius of convergence when we have this inequality. And when I was answering, I overlooked this part. So 9x here. And so I just said you have to multiply by 9 on both sides, and that was actually not true. So I want to make a correction first. And so when we solve the equation, that is x between negative 1/9 to 17/9. And so when we think about the radius of convergence, so radius of convergence is the difference between these numbers divided by 2, because it should be in the middle. So so this is negative 1/9 and 17/9. When we think about the radius of convergence, there is a midpoint, and we go this way and this way. The those must be equal length. So that is 17/9 minus 1/9, which is 17/9 plus 1/9, which is 1/18/9, which is 2. And but we have to divide by 2. So 1/2 times 2, which is 1. Okay. But let's say if we have x/9 less than 1, and then of course we can say that we multiply by 9 on both sides, and then we cancel these out, and so absolute value of x is less than 9, and so this becomes a radius of convergence. So any question? So 11.9 is about representation of functions as power series. So this time, we have a function, and then we want to express that as a power series. And so geometric series is 1 plus x squared plus and so on. X is unknown but fixed number, random number. Then that can be written as summation n equals to 0 to infinity x to the n power. So when we have a geometric series that converges if the ratio is less than 1, right? So that is converges to 1/1 minus x if absolute value of x is less than 1. So x is common ratio. So what we are saying from here is a 1 over 1 minus x can be identified with this series. In this case, what happens is 1 over 1 minus x. X is an unknown number. And so that this 1 over 1 minus x can be regarded as a function. And then that function can be expanded as a power series, 1 plus x squared, and so on. And so that is summation n equals 0 to infinity, x to the n power, when x is less than 1. So this function can be expanded to this power series only if the absolute value of x is less than 1. And this is the power series expansion rule, which you have to remember. So we regard this as representations of functions as power series. So in the problem, this pattern can appear differently. And so instead of x, we may think about 1 over 1 minus x squared and so on. And then when we think about the power series, x will be replaced by what is the format which is written here. So in the problems, x may appear to be x squared and x over 5 and so on. We still can use the power series representation. Express the functions as the sum of a power power series. State the radius of convergence and the interval of convergence. So the original function we have to use is this one, but there will be certain perturbation, and then we have to convert the given format of the function into this format, and we will use this formula. Let's see how to do it. So first problem is 1 over 1 plus x squared. So this time, what I ask you to remember is 1 over 1 minus x equals summation n equals 0 to infinity x to the n power. So 1 over 1 plus x squared, we convert the format into this format, and then we have 1 over 1 minus x squared. And then what we realize is instead of x, we have negative x squared. So that means when we expand that with power series, instead of x, we will write minus x squared to the n power. So this part is negative 1 times x squared to the n power, and then that is negative 1 to the n power times x to the 2n power, right? So summation n equals 0 to infinity, negative 1 to the n power times x to the 2n power. So when n equals 0, negative 1 to the 0 power equals 1. So it starts with the positive number, and then negative 1 to the n power will make the series alternating series. And so the first one will be, it will start from 1. And then when n equals 1, this is negative x squared, and then plus x to the 4th power minus x 6th power plus, and so on. The series converges if we know that this expansion looks like this only if absolute value of x is less than 1. So series converges if absolute value of x squared is less than 1. So that implies absolute value of x is less than 1. So do you have any question about this? I can explain further if you cannot understand. Okay, so we have x here, and just in this case, x is from -1 to 1, and so the length is 2, and half of that is 1. So radius of convergence equals 1. And the interval of convergence will be from -1 to 1, but we have to verify whether the boundary points are convergent points. So we check when x equals 1, then summation n equals 0 to infinity, -1 to the n power, x equals 1 to the 2n power. That equals 1 minus 1 plus 1 minus 1, and so on. So this is an alternating series, and so this diverges. And we can say the same thing for x equals -1, because if that happens, then limit n equals the summation n equals 0 to infinity, -1 to the n power, and -1 to the 2n power. So this part can be written as -1 squared n power, then that is 1 to the n power, which is 1. And that means those two are essentially the same series, and which diverges. So interval of convergence is open interval from -1 to 1. Any question? Second problem is x over 64 plus x squared. X over 64 plus x squared. Again, keep in mind 1 over 1 minus x can be expanded as summation n equals 0 to infinity, x to the n power. So this time it becomes a little bit challenging to convert that to this form. So the first difference we notice is in this fraction, the numerator is a number, not variable. So what I will do will be, I will write x in front of fraction plus, times 64 plus x squared. And then what I want to do is we want to think about 1 minus x. And so this number must be 1 instead of other number like 264 and so on. So the only way we can handle that problem is x times 1 over, we are pulling out 64. And then 64 is 64 times 1. And x squared can be written as 64 over 64 x squared. And so that essentially means 64 times x squared over x, right? And when we convert each term's expression in this way, and when we take out 64, these are taken out. This is 64. And so, so 64 times 1 plus x squared over 64, right? So any question about this? And then so x is x over 1 and 64 was in the denominator. And so we can rewrite that as x over 64 times 1 over, that had to be 1 minus, right? And then minus x squared over 64. And then we are making this part fit into this format, right? Instead of x, we have negative x squared over 64. So we can write x over 64, and then this part will be written as n equals 0 to infinity. That instead of x, we will write negative x squared over 64 to the n power. So what can you do? As we did in the previous problem, we want to understand this as a alternating series. And so this one is x over 64 summation n equals 0 to infinity. This one is negative 1 times this one. So negative 1 to the n power x to the 2n over 64 to the n power, right? We just distribute the power to the numerator and denominator. What we know is at a certain interval, this series must be a convergent series. And x is a random number inside of that. And because we are thinking about the convergent series, you can put this back to here. So we can rewrite that as n equals 0 to infinity, negative 1 to the n power times x over 64 times x to the 2n power over 64 to the n power. And then we would combine all those things. So summation n equals 0 to infinity, negative 1 to the n power, and x to the 2n plus 1 power, and 64 to the n plus 1 power. So any questions so far? So our next goal is we did something similar to the power series, but this is not entirely the same format. So we want to raise that to the power, to the n power. So the way we do it is something like this. So this is, let me go to the next page. This is summation n equals 0 to infinity, negative 1 to the n power times x to the 2n plus 1 power over 8 squared n plus 1 power. So what can we say about this? Just a summation n equals 0 to infinity, negative 1 to the n power times this is x. So let's write down x to the 2n power over 8 squared to the n power times x over 8. And so what happens here is x to the 2n power over 8 squared 2 n power. This can be written as like this, right? And so the same power, so that means x squared over 8 squared to the n power. Right, and so that can be rewritten as x over 8 squared to the n power, right? So the reason we are doing this is we want to think about the radius of convergence. So we have to make the things in this format, x to the n power. So this can be written as n equals to 0 to infinity, negative 1 to the n power times x over 8 times x over 8 squared to the n power. So when this part converges, the entire thing will converge because this is just a fixed finite number. And so the part which we have to care about is x over 8 squared. That must be less than 1, right? And so this is just a positive number anyway. So we can say that this is x squared over 64. That is less than 1. And we multiply by 64 on both sides. Then we have x squared less than 64. So x is between negative 8 to 8. So radius of convergence is 8. And we have to think about whether the series converges at the boundary. So if x equals minus 8, then when we think about summation n equals 0 to infinity, negative 1 to the n power 8, x is negative 8. So we are plugging that into here. So that is negative 8 over 8 times negative 8 over 8 squared to the n power. And so this will cancel each other. So summation n equals 0 to infinity, negative 1 to the n power. And this will be 1, negative 1 squared is 1. and then just a 1 squared n power. This one just equals 1. So it'll be 1 minus 1 plus 1 minus and so on. So this one diverges, right? And if x equals 8, then summation n equals 0 to infinity. So minus 1 to the n power, 8 over 8 times 8 over 8 squared to the n power. So summation n equals 0 to infinity. And this is 1. 1 squared n, this part is 1, everything is 1, and so this is 1. And so this is negative 1 to the n power. And so again, it becomes 1 minus 1 plus 1 minus, and so on. That diverges. Any question? Things are a little bit complicated. In calculation, I think, when we try to convert all those things in this format. The next one is about 9 over 1 minus x to the 5th power. So this is a little bit easier problem. So that is 9 over 1 minus x to the 5th power. And if you think about the power series expansion, that goes like 1 minus 1, 1 over 1 minus x. So that is summation n equals 0 to infinity, x to the n power. So that can be written as 9 times 1 over 1 minus x to the 5th power. And so 9 times this part will be n equals 0 to infinity, x to the 5th power to the n power. Instead of x, we are writing 5 there. So 9 times summation n equals 0 to infinity, x to the 5n power. Just a moment. So I have to write 9 here. Indeed, I cannot recall whether WebAssign accept both answer or only this answer. I'm not quite too sure. You can try and see whether which format of the answer WebAssign accept. But in the written exam, I will accept both. So it doesn't really matter. So we want to think about the radius of convergence, and then we have to think about the where this series converges. And so as long as this part converges, the entire part converges. And so we use only x to the 5th power. So x to the 5th power and take absolute value that is less than 1. Then absolute value of x is less than 1. Therefore, x is between -1 to 1. So any question? So from here, we see that the radius of convergence equals 1. So if x equals 1, then summation n equals 0 to infinity. We just think about this part. If this part converges and the entire part will converge, and if this part diverges and entire part will diverge, right? And so we can think about this part. So 1 to the 5th power, and so each term will be 1. So n equals 0 to infinity, 1 to the n power, and just so we'll keep adding, so that diverges. And if x equals -1, then summation n equals 0 to infinity, -1 to the 5th power, n power, and then that equals n equals 0 to infinity, -1 to the n power. And so this is an alternating series, 1 minus 1 plus 1 minus, and so that diverges again. And so this, which it doesn't include the boundary points, will be the radius of convergence, the interval of convergence. Any question? I think you have to practice. So whatever the subject is, practice is important. The next topic is about differentiation and integration of power series. If summation Cn times x minus a to the n power has radius of convergence, are positive, then what we can say is that we can say that that is differentiable, integrable, and we can differentiate and integrate term by term. So f of x is c0 plus c1 times x minus a plus c2 times x minus a squared, and so on. And then that is summation n equals to 0 to infinity, cn times x minus a to the n power. That is differentiable. And continuous. On the open interval, a minus r and a plus r. And as I said, the differentiation and integration will be just a term by term differentiation and integration. So f prime of x, when we differentiate, the first term will vanish because that is just a number. And the second term, this part will vanish because that is again a number. And then we have differentiation of x is just 1. So the first differentiation is c1 plus the second differentiation is a chain rule. So 2 times C2 x minus a, 1 less power is 1 power. And then we keep on going and going like that. And then the next term will be 3 times C3 x minus a squared, and so on. So that can be written as summation n equals 1 to infinity n times Cn x minus a to the n minus 1. So that came from summation n equals 0 to infinity d dx Cn x minus a to the n power. So term by term differentiation is the differentiation of the power series when the series converges in a certain open interval. The next one is integration, f of x dx. Then that is against, this is indefinite integral. So we have to put plus c. Let's write it down first. And then it'll become n equals 0 to infinity Cn times x minus a to the n plus 1 power over n plus 1. So this comes from C plus summation n equals 0 to infinity integration Cn times x minus a to the n power dx. So term by term integration is the integration of the power series. And after the integration or differentiation, the radius of convergence will not change. So radius of convergence will remain as R for 1 and 2. Any question? So the power series and Taylor series are not really difficult as long as you practice, but I think in the past students had some difficulties with power series and Taylor series, and so spend enough time to calculate it correctly and simplify it correctly. So today is Thursday, and so see you next Monday at the classroom. You can ask me a question if you have.